Hello and welcome to Guiding Assets, the flagship investment podcast for CFA Institute. I'm Mike Wallberg, and I'm pleased to have Ivan Mitov on the show today, joining me all the way from Sofia, Bulgaria. Ivan is the VP and Director of Risk Research for FactSet, where he leads a global team of over 20 quantitative researchers tasked with building and applying FactSet's multi-asset class risk models. Today we're going to continue. It's become a bit of a series on the show, and that's on the application of AI and large language models in our industry. You'll recall we talked about AI and alternative data with Joe Simonian a few weeks back. Morningstar CEO Kunal Kapoor covered how his company is applying AI to fund ratings and customer service bots. And earlier in the fall, Rodri Priest and Ryan Munson described how its many emerging applications were top of mind in CFA Institute's latest member survey. Ivan is yet another PhD holder on the show, so I'm hopeful the good doctor can help guide us through a discussion about the application of large language models like ChatGPT to the processes of risk modeling and portfolio construction. Welcome to the show, Ivan.
Thanks, Mike. It's a pleasure to be here. Thanks for having me.
You bet. Let's start with somewhat analog view into the work you and your team do, as in help us understand the focus of your research and the outputs you work toward for clients. But circa, 2020, 2021, before ChatGPT and the other large language models burst onto the scene.
Yes, sure. So my work and my team is, as you mentioned already, we are responsible for building multi-asset class risk models at FactSet. So I have a group of quantitative researchers. So we are responsible for the entire life cycle of model building that starts from model research. That means that's a quantitative risk model, so market risk, etc. So it starts from the research. Then, of course, once you come up with something that you feel that you want to test and that makes sense, you're doing a prototyping. Usually, recently, we are doing this in Python language. Then once you have the prototype, you start digging into getting some data to fit the model, because risk modeling in general is a very data-intensive exercise. So you need data, historical data, in order to predict future volatility. You would like to calibrate your model based on data. So we get the data, you pipe the data, then you run those, let's say, analysis and see, okay, can I identify being equity or fixed income or any other asset class? Can I find the relevant factors that drive this asset class risks? And this is a cycle of R&D cycle that people are working on, and it's an iterative process. You start with the idea, you test it, you see the outcome. Is it good? You back test it, and then at the end of the day, you come up hopefully with some good model to implement and release to our clients.
So if it's iterative, then it's obviously can be quite labor intensive in terms of just trying to manage that data and turn it over and refit it to new ideas and hypotheses. So I imagine, I guess the question to you is, where are you seeing the biggest benefits of large language models in your day-to-day? How does that fit in?
Yeah, thanks for this question. Effectively, I see the benefits in three main directions. I will start with the first one. This is with improving the efficiency of how we test our ideas. And this is, of course, we as quants, me and my team, we are coming from backgrounds of science. So let's say virtually anyone on the team was able to understand in a sufficient, not in depth, but sufficient level of detail, how those LLMs work and why and when they could be used. And of course, because they are text generators, we decided, okay, let's generate some text, but not in English, but in this case, in programming language. And that's, in our case, Python. So you can be very effective when you have some idea, just really use the large language model to bring you back some code snippet that you can test. You can test your idea easily, and it's really efficient, I would say. That's, of course, you need someone to drive the process. Usually this requires some experience. If the more experience you have, that's my observation, the more experience you have, the more efficient you could be by getting relevant outcomes from those large language models. I can give one example. It's really, it was summer that we were trying to see, okay, can we employ Nelson Siegel's Fanson model, for example, which is very, very popular for interest rates. and fitting the yield curve. Can we try it, fit it on some other domain that's not interest rate? And it took us like 2, 3, 4 hours from starting to asking the model, okay, what is Nelson Sigio? Can you give me some code base to fit the model? Then we figured out, okay, this model could be somewhat unstable when you fit it. Can you make some constraints on the parameters, etc.? It's a little bit technical, and from start to the end, to get some tangible outcomes, some results to discuss with our group. Within the group, it took us like 2, 3 hours, which is compared to, let's say, a couple of years ago, it could take maybe for somebody more junior, 3, 4 weeks. It depends. So you can see the difference.
So it allows you to effectively code these new ideas in, and at least to get them to a level where you haven't tested them obviously yet, but it lets you debate these ideas and see whether there's any merit in them.
Definitely speeds up the time from idea generation to something tangible that you could discuss with the team and see, okay, is there any value? But of course, getting real and good answers that are valuable, it requires proper conversation with the model. It's really important how you lead the conversation, and you need to have, let's say, in my experience, you need the more experienced person sitting in front of the model, the greater results you get. For example, Stephen Covey says in his 7 Habits book that everything is created twice. First is mentally, then it's physical. So one needs to imagine, let's say, the project or the model, the steps that you're going to do to execute in order to build the model. And then those smaller pieces, smaller steps or smaller tasks you can pass over to the large language model and get some results. And I have an analog. I usually think about it, this process working with a fresh graduate or very motivated intern that, if you wish, with no practical experience, but very knowledgeable. So they have absorbed a large amount of information. They have read an unimaginable number of books and articles that no real human can read for the entire life. But then, and they're prepared for quote unquote real life tasks. Then if you have some mentor or some senior person that asking the right questions and guiding them through the process, that they could achieve exceptional results. It might sound strange, but just think about it. Imagine you someone that has read a lot of books, right? So you ask questions. Sometimes they give you maybe incomplete answers. Sometimes they give you maybe a little bit wrong answer, because that's a feature of those models. But then with few iterations and a little bit of guidance, then you can really get and achieve outstanding results in terms of efficiency.
Earlier in their career, they have data, but they don't know how to turn that into information effectively. So they don't have that experience, right?
Yeah.
So I actually wanted to push in a little bit on that, because effectively what you're describing is the tools are sharper and more efficient, but to your point, that act of creation has not really changed insofar as you need experienced people to dream up those hypotheses to test, to identify the factors to measure and manage for. But I'm curious, I'm conscious when I say this, that this question has been applied to every major development really over the last 100 years or plus, from the calculator to the internet. But if the tools were to, say, disintermediate those junior coders, what happens when the senior people retire, if the pipeline of people behind them don't actually get that crucial experience to be senior people themselves? How do we deal with that?
Yeah, I remember we had this discussion or this topic. We touched on this during our preliminary also, but junior people, I was thinking a lot on that, and there will be always a room for talented, educated, and motivated people to enter the job market. And human brain is an exceptional creation of the nature, right? So a supercomputer could accumulate an enormous amount of energy bills. For example, our brains figure out what to do in seconds, and it's something that it's really powerful. And over the years, I met two type of people. So two I worked with hundreds of people. I hired a lot of them, and I could classify the people in two main groups, I would say. If you think about a complex project, there are bits and pieces that interplay with each other and depend on each other. And there are two types of people. The first group, those are people usually approach any task or problem first in width, like just to see what's going on there. And then they try to see the big picture and why they are doing what they're doing. And then they dig deeper into details if it's necessary. And of course, the best is if you have people that could dig deeper. And the second group is the group that they first want to understand something in the very tiny detail before they feel comfortable to move to the next step. And those people are usually great at solving math problems. And sometimes they struggle to see the big picture, but that's not a problem given that you have allocated them to the right project. And in my opinion, the large language models would help boosting the efficiency of the first group because they see the big picture. Okay, I can use this for this. I can use this for that purpose. Let's combine them. And then the efficiency will scale. But on the other hand, the evolution of those models and evolution of those models and technology requires sometimes the people from the second group that they could go into the details. They could understand the tiny details and make contributions. So I think there will be always room for and place for people join, talented, motivated.
And continue to be an enabler then of the existing talent that you have. And I wanted to actually talk about that a little bit. And that's the description of, you talk about the first type and they're having these ideas sort of generated for them to debate and look at. One of the criticisms that are out there, of course, of these large language models is sometimes you can't always trust what they give you. To put it to an extreme, they say they lie, right? And it's easy if you say, write me an essay about Napoleon and you read it and it takes you 10 minutes to read it and you realize that there's like 10 facts in there that aren't true. But how do you vet that if you're looking at a model and it's coming back with thousands of lines of code? I mean, is that easy for folks in your profession to go through and figure out whether they put something in that's wrong? Or like, how do you test whether the data is correct or not?
Yeah, usually that's a good question, but I think you cannot just blindly take out what the model is providing. You need to put some experience and review what's going on. And that's why I'm saying, at least what I see, you could boost your effectiveness and efficiency in using the large language models for doing what you could do, but you don't have time, or they could do it like hundreds of times faster than you. But then when you see the result, you can easily understand, okay, that's an error, or here it's a suboptimal, or I would like to use another more advanced package of Python that I know from the practice that gives more or better results. So you need to have people working with the model and reviewing the results. Like, that's why I made the parallel with the intern. If you hire some super smart intern, you cannot just give them some task and without any guidance, right? So they could be perfect, but sometimes you just think you think that you're doing the right thing, but at the end of the day, you might do something that's irrelevant, so to say, not wrong, but maybe irrelevant or not on point, or sometimes even wrong. So yeah, you need people driving the machine.
For those of us who are only now starting to tinker with ChatGPT, what advice can you give about developing effective prompts for using it to do more complex things as you are?
Developing effective prompts. There are multiple materials out there and good references, but what I would say is start simple. Start simple by asking questions and providing some context. That's the general guideline. You cannot just throw some very complex question and say, okay, give me the answer. That's why I'm saying you need to think about the process. How would you do that? How would you approach the problem? Okay, I'll do that. I'll first maybe read some literature. Give me some literature on that. What are the key reference? Okay, then I need some code to test the idea. Give me some code to test the idea. So that's why I'm saying you break it down to some pieces meaningful and pass over to the model only the ones that you feel confident you could get value out of it.
Gotcha.
Of course, that's my viewpoint on the matter.
Mm-hmm. Yeah, start simple, sort of build it out, and go more complex as it goes when you feel confident that what it's giving you is...
Providing more context is really important because it's a text generator and it starts converging to something that's more relevant with iterating over and over.
Right. One of the main benefits that keep coming up when I ask this question of guests on the show is, folks talk about communicating with their clients or with their management team. And I imagine that in the seat that you sit in, that's particularly difficult given, the complexity of the stuff that you guys are doing. So how are you guys using it for communicating?
That's a great point, and that's exactly how I see ChatGPT and GPT-4 as very powerful. So you can have some ideas like 2 bullet points, and usually quant researcher and people from engineering background, they shy away from making presentations or executive level summaries. And that's really useful. You can have some ideas or some bullet points, and then you can ask ChatGPT, can you create like 2-pager explaining this? Then you get the results, you format, you review, of course, to see if there is something that's obviously wrong. And that's very, very useful. And the third potential benefit is model exploration. So when it comes to extracting valuable information from the large language models could be helpful, as I said, if you provide them context and start asking questions, it could be really... You can think about it as a very complex and very smart search engine. Okay, I need to know about this topic. And the more the topic is discussed across the industry, or the more relevant results you could get, because this model is educated on this. And then you can use it as an efficient way of coming up, digging into some topic. And then, of course, you need to spend your time understanding what the other people have done.
Can you give me an example of what you mean by that, Ivan?
I can give you an example, like say, if you want to explore a new model, as I mentioned the Nelson Seeger, you want to see, okay, you have some idea, what is this? I have pretty good idea, but let's say I give this to someone else, like years of experience, said, okay, I want you to test this, figure out what this model is and how it works, and read it, do some prototyping, and provide to me, summarize some results for this asset and present this to me, let's say, in 2 weeks. And that's where people can use it. Start asking questions. What is this? Give me some references on this model. Then checking the reference. What are the most widely used areas that this model is applied? What are the constraints that you know about? And because the model has read a lot of literature, they can provide you some reasonable and fast information that you could then use. And of course, you need people who can read the actual information. What I mean is that the model cannot solve your problem, but can provide you a lot of references, like enhanced search engine, so to say. Example was clear, but that's an example.
I think so, yeah. So effectively, you talk to one of your junior analysts there and say, okay, talk about Nelson Stiegel, like have a look into this and, understand what it is, because next I'm going to ask you to see how it might relate to the futures market for some commodity or something. You could say,
commodity.
Maybe there's some type of a relationship there that I want to see if there's, I can find some correlations between how these things behave. Cool. This is really interesting stuff. It's hard for me to imagine these models kicking out their own code. It's kind of like going back to all of the doomsday scenarios where they become self-aware, but I know that's not what you're describing at all.
That's my use case. I mean, I'm pretty huge fan and enthusiast of reading neuroscience literature. I like it. I think the human brain is something that is still to be explored and understood, because like figuring out a lot of stuff, like millions and trillions of decisions every second, like using the power of a 60-watt light bulb, it's different, right? And the evolution of billions of years, it's not something that you can easily replace. But yeah, we're doing progress. I mean, the industry and everyone.
Yeah. The ultimate computer up here, hey?
Yeah.
So, Ivan, we're coming to the end of our conversation here. Unfortunately, I'm going to ask you our final question here, which is, what was your first job in the industry? And if you could go back and take yourself for coffee on your first day, what key piece of advice would you offer yourself?
Well, my first job was 20 plus years ago. I started as a quantitative analyst at a local startup here, Finalytica, that we started. We decided that we were going to build the best possible risk models, capturing fat tails and extreme events very well. We have patterns that are now part of FactSet, and that was my first job. I spent a lot of years. My entire career was spent on, let's say, technology vendors. Like we on the vendor side, we're creating models and software for our clients. What I would say to myself: be curious, be curious to understand more, deliver more than expected, and everything will be okay with your career. I would say that's the main thing. Be proactive, be open to new initiatives, and be collaborative. That's very important because you're working with people, yet still you're working with people, not machines. Although sometimes you work with machines, but people working with people is extremely important.
Good advice. I've been speaking today with Ivan Mitov, VP and Director of Risk Research for FactSet. Thanks for coming on the show today, Ivan. It's been a real pleasure.
Thanks for having me, Matt.
I'm Mike Wallberg, and this has been Guiding Assets.